lesson today, we'll be talking about the real number system. Real numbers are made up of several sets of numbers that you've been exposed to over your past experience in mathematics. The natural numbers, sometimes called the counting numbers that you learned earlier in elementary school, begin with 1. 1, 2, 3, and these little dots mean continues on to infinity. The only difference between your natural numbers and your whole numbers are that your whole numbers include the number 0. Since you could not count with 0, that was not included in the first number set that you learned. Then you were introduced to integers. Now, the integers, as you see, are whole numbers, and the negatives are their additive inverses in opposite directions. Whole integers have no fractions or no decimals. Then you come to the rational numbers. Rational numbers can always be written as a ratio. As you see in the beginning of the word rational is the word ratio. A rational number either repeats or terminates. Finally, within this number system are the irrational numbers. Now, irrational number cannot be written as a ratio. It is a non-repeating number, and it is non-terminating. It would be like the square root of 2. If you put that in your calculator, it would give you some long answer, and it would keep going, but it would not repeat or terminate. Or you've seen the letter pi. Now, I know that we represented pi by 3.14, but pi never repeats or never terminates. Now, don't get confused. All radicals are not irrational numbers. The square root of 25 can be simplified to 5, so therefore the square root of 25 is not irrational, but rational. All of these numbers sets that we talked about this morning, natural, whole, integers, rational, irrational, all make up the number system of the real numbers. And you'll be working with real numbers throughout this textbook. There is a chart on page 34 of your book that you might want to look at that further explains how these number systems relate to each other. Also in this section, we will be talking about the concept of absolute value. The absolute value of a number is the distance from the origin. You can go units to the left or the right of the origin. If you go 2 to the right or 2 to the left, you've gone the same distance. It's like traveling to a town or traveling back. You don't say you've gone a negative distance. The absolute value of a number is always positive. When you take the absolute value signs are these ugly large bars. The absolute value of a negative 6 would be 6. The absolute value of 5 would be 5, not negative now. The absolute value inside this, these absolute value bars of negative 2 would be 2, but the negative outside keeps it negative 2. So every time you see an absolute value bar, that does not mean that it would be positive, but it means that the value inside will become positive, and you have to adjust it to the value on the outside. So if you were talking about the distance from 0, positive 2 would be 2 units. Negative 2 would be 2 units, so the absolute value of negative 2 would be 2. The absolute value of positive 2 would be 2.